In today's note, we're going to take or combine all the things we learned in the past lessons about solving linear systems and apply it to solving word problems. So in these types of questions, you can use whatever type of method you find easiest. Again, you may look at the actual equation or the actual equations and see that there is one method that tends to be a little bit easier or simpler to solve. So that's what I'll be doing. If you choose to do it or solve it in a different method of the three, so graphically, by substitution or by elimination, either way is fine. I would suggest not doing graphically unless you're using a graphing calculator. However, you will have to use, in terms of assessment, I'd say one of substitution or elimination. But again, whichever way you choose is up to you. So the steps for going through and solving these types of problems are: first, we need to determine the two unknown quantities by reading the question thoroughly and carefully. So whether you have to read it multiple times or just get in the habit of reading the questions, and if you're not sure, asking for help, and then just kind of constantly practicing that, you're going to look for two unknown quantities. Next, you're going to introduce a variable for each unknown, so we need to know what to let each variable represent. Then you're going to come up with two equations using both variables. Then you're going to solve the system based on one of those three methods. We're just going to be sticking with substitution or elimination, and if you need to, check your answer. And then answer the problem with a statement. So again, the key thing would be coming up with those equations. That's probably the most difficult part, and then from there you can review the last lessons on how to solve by each method. So in the first example, Sam has $113 made up of $2 coins and $5 bills. If there are 31 bills and coins, how many $2 coins are there? So we're going to need to come up with our two variables. So I'm going to use x and y, so let x equal number of coins, and then let y equal the number of bills. Those are my two unknown quantities. I don't know how many bills or how many coins there are. So from there, I need to come up with my two equations. So by reading the question, I can see the easiest one first is going to be x plus y, or basically the number of coins plus the number of bills is going to equal 31. I'm going to label that equation 1, and that just comes from this statement here, 31 bills and coins. The next equation that I'm going to come up with is based on the actual amount. So the idea that there's $113, it's made up of $2 coins and $5 bills. So that means $2 times the number of coins plus $5 times the number of bills has to equal $113 in total. And that's my second equation. So what I'm going to do now I'm going to solve by either substitution or elimination. I have my two equations, so now I just need to pick which one I'm going to do. So I'm going to use substitution, so I'm going to rearrange equation 1 for y. Again, whichever, you can choose to rearrange for a different equation, but I would suggest picking equation 1 because it is the easiest to rearrange because there are no coefficients in front of the variables. So in this case, what I get y equals 31 minus x. So again, go back and review rearranging equations if you have to, or go back and look at the lesson. And now I'm going to sub this equation into number 2. Right, I'm going to sub it back into the other equation. I'm going to do that up to the side here. Let me kind of reorganize this. So now I'm going to substitute this in up here. So I have 2x plus 5y equals 113. I'm going to substitute it in, so it's 2x plus 5 times 31 minus x equals 113. Now I'm going to go through and solve. So 2x plus 155, because again, remember, this 5 gets distributed into both parts, minus 5x equals 113. I'm going to group my like terms together and move the positive 155 or the plus 155 over. So kind of doing a couple steps in one. So I get negative 3x equals 113 minus 155. Get negative 3x equals negative 42. And now to cancel out the negative 3x, I'm going to divide by negative 3 on both sides. Cancels out on the one side, and I'm left with x equals 14. So that is part of my answer. So now I know how many coins there are, but because we're just going to go through and we're going to finish up the question, I'm going to sub this answer. So sub this into, I'm going to sub this back into number 1. So I get 14 plus y equals 31, and I get y equals 17. So we didn't need to do that based on the question, but it doesn't hurt to go through that full step, because that would be the full solution. And then finally, therefore, there are 14 $2 coins or toonies. And that is the solution to example 1. The next type of problem we're going to look at is distance, velocity, and time problems. So these are ones focusing on questions that deal with distance and velocity. So in this example, it is 395 kilometers from Ski Valley to Vancouver. Ivy made the trip in 6 hours, traveling by bus and by train. The train averaged 700 kilometers per hour and the bus 600 kilometers per hour. How much time did she spend on the train? So what we're going to do here is let x equal the number of hours on the train, and let y equal number of hours on the bus. And the reason it's a distance, velocity, time problem is that we're going to be focusing on these scenarios, looking at our distance, the velocity, and the time. And this is stemming from, if you think back to science, our distance, velocity, time formula. So distance is equal to velocity times time. And we're going to use that to help us come up with our equations. So if I look at the first example, dealing with a train, then we're dealing with a bus. Those are our two scenarios. I know the time spent on the train is going to be represented by x. The time spent on the bus is going to be represented by y. I know the velocity of each, so the velocity of the train is 70, the velocity of the bus is 60, and I know the distance traveled is going to be 70 times x, and the bus will be 60 times y. And the reason that we're doing this is to help us come up with our formulas, because the only thing we're dealing with is distance, velocity, and time, and we can come up with our full equations. So there's two other pieces of information that we know. So I'm going to highlight kind of what we covered. We got those two. We know what the variables are going to represent. The two other pieces of information, the trip is 6 hours long. So that means if I look at the time, x plus y has to equal 6. And I know the total distance, 395 kilometers. So my distance column has to add up to 395. So that's where I'm getting my two equations from. So the first equation, and I'm going to do it off to the side here, is x plus y equals 6. And then my second equation is going to be 70x plus 60y equals 395. So those are my two equations. And now I can go through and either use substitution or elimination. We could use substitution again because it's very similar to the last one. However, I am going to mix it up and use elimination just to show multiple examples. But again, when it comes down to it, you can choose whichever one you feel comfortable with. So if I'm going to solve by elimination, I can see that the coefficients in front of the variables are not the same. So I need to pick one and change it. I'm going to change equation 1 because I can easily multiply that entire equation by a value to get one of the coefficients the same. In this case, I'm going to take equation 1 and multiply it by 70 so that I get 70x plus 70y equals 420. And then my second equation, 70x plus 60y equals 395. And now I have to choose, do I subtract or add my two equations? Because I can see that the coefficients in front are the same sign, I'm going to subtract. But again, remember, you're subtracting the entire equation. I'm going to put my columns down just to help me organize things. And when I go through, this one becomes 0. 70 minus 60 is 10y, then equals 25. So now we have 10y equals 25. Just simplifying it, I'm going to divide both sides by 10. So I get y equals 2.5. So I have part of my equation now, and the last step, I have to sub this into, I'm going to pick equation 1 because it is the easiest. And so again, when I do that, I'll just do it off to the side here because it's just a quick calculation. X plus 2.5 has to equal 6, so x equals 3.5. So therefore, she spent 3.5 hours on the train and 2.5 hours on the bus. So that is an example of a distance time or distance velocity time problem. Example 3, we're going to look at an example that focuses on percentages and solutions. So here we have a chemist mixes hydrochloric acid solutions of 30% strength and 40% strength to form 100 kilograms of a 34% strength solution. How many kilograms of each should be used? So here what we're going to do is we're going to create another table. We're going to look at volume. We're going to look at, in this case, the 30% acid, the 40% acid, and the 8% mixture. I'm going to let x equal the amount of 30%. I'm going to let y equal the amount of 40% and go from there. So if I'm looking at the volume or I'm looking at these two situations, I have two things. I have the volume of the acid and the volume of my solution. Right? Remember, in science, solution is a mixture, and when we're dealing with acid, we usually dilute it with water. So the solution is actually a mixture of the acid and water. And I want to know how much of each solution that I'm going to do. So I know for the solution, I know the easiest one here, the amount of acid plus the amount the amount of 30% acid plus the amount of 40% acid is going to have to equal 100 kilograms. From there, I'm going to look at the amount of pure acid, and in this case, the amount of pure acid in the first solution is going to be 30% or 0.3 times X. Because if it's 30% acid, then 30% of that amount is going to be acid. 0.4 times Y, so 40% of the amount is acid. And then lastly, I know the complete amount, right, if I highlight it up here, so I know 0.34 times 100 will give me the actual amount of acid in that final solution. So here I'm going to come up with my two equations. So equation 1 is going to be x plus y equals 100. And equation 2 is going to be 0.3x plus 0.4y is equal to, and then I'll simplify this, which would just be 34. So and this is going to be my second equation. So here what I'm going to do, again, I'm going to go through and solve. Again, you can choose whichever way to do it, substitution or elimination. Again, whichever way you choose to do it is up to you. I'm going to choose to do elimination again, but again, you can choose whichever way you want. By doing it by elimination, I can see that the coefficients again are not the same in front. So what I have to do is I have to multiply one of the equations by a number so that the coefficients are the same. In this case, I'm going to choose equation 1 to multiply or to change. So I'm going to take equation 1 and I'm going to multiply it by 0.3. I'm going to try to cancel out those x's. And when I do that, I get 0.3x plus 0.3y equals 30. So the 100 times 0.3. Equation 2, I'm just going to write again. So 0.3 x plus 0.4 y equals 34. I even kind of keep it the same colors we've been using. And now I need to figure out what am I going to do. Am I going to add or subtract these two equations? By looking at these two equations, I can see that the coefficients in front of the x's are the same, and I can see that the signs are the same. So in this case, because the signs are the same, I'm going to have to subtract the second equation from the first. I'm going to draw my columns to help me organize or keep things in the same spots. So when I subtract the first one, it's just 0. When I subtract the second one, I get negative 0.1. And when I subtract the second one, I get negative 4. Sorry, it should be negative 0.1y. So now I've eliminated one variable, so I can solve. And divide by negative 0.1, divide by negative 0.1. They cancel out, and I get y equals 40. Then finally, I'm going to sub this into, I'm going to go back to equation 1 because it is the simplest one. So I know that x plus 40 has to equal 100. So x equals 60. And therefore, they used 60 kilograms of, and then x was 30% solution, so 30%, and 40 kilograms of 40% solution. And that is how you solve a percentage question. The last example we're going to look at is a break-even question. So in this case, or this example, to send a package from any city in Ontario to another city in Ontario, Fast Express charges $5 plus $1 per kilogram. So basically $1 per how much the package weighs. For the same service, Tomorrow Delivery charges $3.50 plus $1.25 per kilogram. When will the cost of delivery be the same for both companies? So my two variables in this case, the only two unknowns, so let C equals cost and let N equals the weight, so the weight of the package. So my two equations, I'm going to have one for each company. So the first one, we're going to look at Fast Express. So Fast Express, so the cost is equal to $5 plus 1 times N. And that's going to be my first equation. My second equation is going to be for the Tomorrow Delivery Company, which is $3.50 plus 1.25 times the weight, or times N. And that's my second equation. Here I'm going to use solving by substitution. So I'm going to sub equation 1 into equation 2. Again, based on this, you could do it for either one. The nice thing is they're already arranged for an equation. They're already isolated. They're both set equal to C. So either way you choose to plug it in, 1 into 2, 2 into 1, it should be the same thing. So when I do that, I get 5 plus 1N is equal to 350 plus 1.25N. So everywhere I saw the C in the second equation, I replaced it with what C equaled from the first one. So that's why we get this. Now I'm going to solve. So what I'm going to do, I'm going to do this in kind of 2 steps, and I'll just do it step by step. I want to get my letters all away from each other. So I'm going to move the 5 over. So I get 1N equals negative 1.5 plus 1.25N. I'm going to move this over and get my N's together, and I'm going to get negative 0.25N equals negative 1.5. I'm going to divide to cancel out and get N by itself. Cancels out on one side, and I'm left with N is equal to 6. And then if I want, I can sub this back into equation 1, so that C equals 5 plus 1 times 6, and C equals 11. So therefore, the cost will be the same, and in brackets we can say $11 when the package weighs 6 kilograms. So that's an example, basically one from each type of situation that you're going to be looking at. Again, you may see different options, but again, try to follow the same steps. Read through the question, come up with two unknowns, and designate a variable for each unknown. Come up with then 2 equations that involve those unknowns, and then once you do that, you can solve by elimination or substitution. So again, the hardest thing will probably be coming up with the equations, but again, take a look at them, look back at these examples, look back in your textbook for more examples if you need them, and then hopefully from there you're able to get into solving, which you can then refer back to previous lessons.